Dear students, I want to welcome you to the practical exercise for finite element method using Altair HyperWorks here on the Frankfurt University of Applied Science. The course is held this semester with Professor Huss and myself, Stefan Vogel, and I want to thank Nahid Mia for preparing all these documents. I will give you a brief overview over the finite element method, and then we have a short introduction on the product this time. The Altair products have a very broad variety of all CIE methods, including CFD and multi-body computations. But we will focus on finite elements as this course. We are distinguishing between geometrical models and finite element models. Out of the geometrical models, we are forming our finite element models. The simplest geometry model is a point, it's a 0D element, and we have lines existing of 2 points, and it's a boundary condition, and the combination or the connection between it's a line. Then we have a surface, so it's a 2D element, and then we have solids. They consist of a 3D volume element. In our finite element representation, we have 1D elements. So it's a element shape is the simplest one is a line, but it can be also curved. So we have the type, it's a bar, rod, beam, pipe, and some other special elements we can look up in the documentation. We also have 2D elements. 2D elements have normally the shape of quads or triads. The element type could be a thin shell, where we have a very thin, and we have a very low restriction against bending, and then a blade, so we have a higher resistance against bending. Membrane, where we don't have any resistance against bending. Plane stress, so all stress is happening in the 2D area, and we don't have one stress in this case in the y direction. And the plane strain, that means that we have mostly focusing on the xz axis in this case, and we don't have any strain in the y direction. So plane stress, no stress in y direction. Plane strain, no strain in y direction. That's the difference. So our 3D elements are what we are looking at our course is tetras and hexas. We don't use so much pentas or pyramids, but they're also possible. The element type is solid. We also have 0D element, so it's a point element where we can concentrate a mass on for our simulation of, for example, eigenvalues and eigenmodes. So we have further elements like a spring, damper, gap, ridges, and welds. Ridges we have so-called RGB2 and RGB3. It's a little bit different called in the documentation of Altair. One is called just rigid, and I think the other one is called RGB3. I will explain you now a little bit graphical user interface, but I will do it on the program itself. Okay, I want to show you the usage of the program. You have two chances to use a Hypermesh. You can start it from Hypermesh or Hypermesh desktop. I will show you how to do it from both. In both cases it's a very small difference, but I will show you the difference. I start with Hypermesh. It's asking for the solver you want to use it for. So your answer is obstruct in our case, so we acknowledge obstruct, and I want to give you a short explanation of this GUI, the graphical user interface. You have the main menu here, so it's quite easy like all other Windows programs. So you have the toolbars, so masking, we go through some of this later when I have a model opened. And then you have main menu pages here. It's about geometry, 1D, 2D, 3D, analysis, tool and post. Geometry is about all geometry. 1D includes also 0D characters. So that's what I told you before. Like you have ridges, which is RP2 also in the literature, and RP3. We also will use this both of that and explain the difference later in the course. Then you have 2D and 3D elements. Everything what you can do with 2 or 3D. And then you have analysis, everything what is used for solving, and then you have tool like deleting, project, position, permute, mask, delete, whatever you do with geometry or also finite elements. Post, it's quite easy, it's for post-processing your results or part of your results. So everything you can do here, you can also do it with a use of the main menu, but we will come to this later in the practical training. Here, that's where your objects are located. We will also see how to pan, zoom, rotate or whatever. And here we have the graphics area, so we will also explain how it's used later. And this is our tab area, like again later, because then I have something in model loaded and I have more to explain to you. And then I have the status bar. The status bar is very important because if you get an error and you don't know why, at least it's giving you a hint what you should do. Okay, that was the Hypermesh. Now we open not the Hypermesh, we open the Hypermesh desktop. And we also accept that we're using OptiStruct. And what we see in addition is this icon here, where we can switch between different other Hypermesh or HyperAlter tools, which is very, I would say, handy for using post-processing and Hypermesh together. Okay, so I recommend you to use the Hypermesh desktop environment. We have now a closer look when we open a model. How we open a model, file, open, model, and I use one of the examples we are going to have in chapter 2. And now we look at the hierarchy, how it is assembled here. So it's this assembly hierarchy, which is like in the same way like our component hierarchy. So you see if you click this here, that means that the geometry is switched on or off. It's also done in assembly hierarchy. Or the elements are switched on and off. In the 2D it's totally empty. It was just built that way. You can also delete it if you like. So you go either on a right mouse click and put on delete, and you deleted it, and it's vanished from the assembly and from the components. What we have here is a 3D mesh. If we click that off, so it's not shown anymore. If we click it on, it's shown. We could also change the color of that with a double click. We change the color, it's fine. And we also have a color for a solid model. I flip it now to a different color, and you already see there's a change by it. But now we have the coloring by component, which means like this is a component, and if we have a different component, it's shown a different color. We can also color it by a different way by properties. There's also a property collector, and our 3D elements have a certain property. And we are also can put it per material. It has the same color. Now I change the color of the material. I double click here, put it on that. So you see, when I flip here now by properties to material, it's shown by a different color. But it's still shown by the color of the component. Change that. Then you see everything which is not a material is still valid by the component collector. Here it's also the assembly. What you can see here is that assembly and component are the same. It's a little bit, you will see maybe not in this course, but maybe in advanced course, why is it that way. But it shouldn't disturb you at this time. Okay, now we have this, let's say, elements and volume body in. I flip now my 3D mesh off, and how is a representation of my geometry here? So I have a solid, that's what I know, you don't know it. So now we have a wireframe, but I can also put it wireframe and surface lines. So you see also surface lines straight. So we have a very smooth, nice surface, but it could be also different if you generate the surface in a different way. But you can also flip this representation to here shaded geometry and edges. But you can also remove the edges by just putting to shaded geometry. Here you can flip on transparency. But in normal conditions you don't want to flip it on for all components, so you select the component. In our case I want to do it on the solid model, and I go on a return and I switch quite a high transparency mode in, and you see it that our solid now turned transparent. I think I put our elements now to transparent rather than solid. Let's see whether it works. I go to that, flip to 3D elements, and select that by putting on the right mouse click, return, put the transparent on a high level, but it doesn't work. Elements you can put a transparency on. Why is that? In principle it would be possible, but even nowadays graphic cards would be a very hard challenge for them, because we have thousands or maybe more. Let's see, I can use a count. Let's count here. We need element entities and I want to display it. We have 42,800 elements. So this everything would be transparent, and the transparency would add, so it would be very, very slow on moving. Okay, now we showed that geometry, how it's represented. So I can do the same here. I put it on wireframe on skin only, so you can see all elements, how they are connected on the surface. It's very hard to see, but it's just the surface. It's easier to see if I take opposite thing, not opposite, but if I put the wireframe elements on, so every line of our elements edges is shown. So you see it's very, very, very a lot of lines, and then you can imagine how it would be if I would put transparency on. Okay, so I can also go on transparent elements. So you see it's still, you have something like what I said before, transparent elements, but they are more or less totally transparent. Let's see whether I can change the transparency of that. So put the transparency on the lower level, and let's see, but it's not really changing something. Okay. Now I can do the same, but my surface is switched on, or my element is switched on, and now I just put the feature lines on. So feature lines are the lines which are which is used by the mesh generator to generate the meshes. And here shaded elements. Let's see. I put the transparency to a higher level. I don't see a difference now. Actually, to be very honest, I didn't use it so much. I have okay. Oh. Actually, I've never used this representation. Okay. Whatever. Now I show you how to move your graphical user interface. It means move your geometry and your mesh. I do it already, I would say, automatically. So every time I move, I press my control, left mouse, let me rotate it. Middle mouse, I can select the area where I want to zoom in. If I have a very small click, short click, I zoom out. With a wheel, I can zoom in and out. And with a right mouse click, I can pan. We have some standard views up here. And with that, you can go back a few. And with that, you can, sorry, I scale in or out, and with that you get it centered on the surface, or get it centered again. This is isoparametric view, and this is where you flip the sides, reverse view. With that, with the left mouse you zoom in, with the right you zoom out, and with that you can zoom in. With that, oops, no, I think that, so you can move out and in with the left mouse button, but you have to click with the right first. It's a little bit strange, and here you can rotate, and with the right you can roll it, so it's automatically, it's not really stopping. So it's to show maybe some person your body, but be aware it's normally slower if the graphic card is under more load. This is pan, and here you rotate on the one axis. With a right click you rotate in a different direction, up and down on the rotation mode, and this axis too. Okay, I don't want to go into this guys here now. This is to make pictures of it. Here is to measure weights, distances, lengths of edges and features. Here, that's what you already I showed you. You have a count, and loads and model summary we will have later. Okay, I think I gave you already quite a good overview now, and okay, be patient, and chapter 1 will be online soon.